All right, philosophers, let's do our homework. Unfortunately, I'm having to record this in my house where the babies are awake, so don't be surprised if you hear some craziness in the background. Um, all right, the first one. Oh, and you may have noticed that this is just basically the exact same thing that you did for the last homework, except now we're doing our new rules. So um, the way this will work is I have the homework kind of back here. I have the rules that we're going to use over here, and this is my tablet that I'm working on, and I'm going to be writing it out over here. So our first problem is if P then Q, if Q then R, and we want to know does that entail if P then R. Now, the first thing that we do for all these Tableau is you write out the initial list. And the initial list includes first your premises, right? So if P then Q, then if Q, oh, oops, sorry about that. If Q then R, and then remember the premises and then the negation of the conclusion. This is kind of what we were doing when we were doing the Tableau, I'm sorry, the truth tables, and we were worried about is it ever the case that the premises are true and the conclusion is false. That's what we're doing here. We want to see could the premises be true and the conclusion be false. Notice also what I'm going to do here. I'm going to put a not, and in parentheses I'm going to put my conclusion. And the reason I do that is because if the parentheses were not there, let's say the parentheses were absent, this would say instead, this would say if not P then R. That's not what we want. What we want to say, it is not the case that if P then R. It's not the case that the whole thing, right? So the not only applies to the whole thing if it's the whole thing is in parentheses. All right, so now what we have to do is just apply rules. And here are my rules over here. All of these are if-then statements. One of them is a not if-then, and the rest of them are regular if-thens, right? So here are my two if-then rules. One of them is a regular one, and one of them is the not. Now here is just for style points, I like to go with the one that goes straight down, not the one that splits off, just because then you don't have to write as much. But if right now, your head is swimming, I wouldn't worry about that rule. That's not really a rule. That's just this makes things easier. So this one says when you have a not if A then B, then you go A and then not B. So my A is the P, right? This first thing right here in this slot is the P, and the thing in the B slot over here is the R. So I'm going to say P and then not R, right? So that's what I'll write over here. P not R. And then I'm going to check that to make sure that I know that I did that one. And then I will, oh, the check's not showing up for some reason. Oh well, oh, there it goes. There's a little bit of delay on this thing, unfortunately. All right, now I have these these two things right here. Oh, by the way, now that this is down here, P not R, there's nothing more you can do. There are no other rules to apply to those two. That's done, so you don't have to check them. You just that's what you want to get it down to. Now I have if P then Q, which is like if A then B, right? So then whatever's in the A slot is going to be not A. Whatever's in the B slot is going to be B. So P is in the A slot. That's going to be not P. Q is in the B slot, so it's going to be just Q, right? So I'll do that down here. P, Q. All right. And now, oops, sorry. Now check that one. And now I have one of them left, right? The if Q then R. I'm going to do the same exact thing. But notice here, I'm going to apply this rule in other words. But notice here what I have to do. I have to apply it on both sides. Q, oops, Q. Did I not do? I messed this up, didn't I? Yeah, I forgot to put not P. I'm sorry. Not Q, then R. And I have to do it on this side over here too. Not Q, then R. Okay. So now, and the reason this rule is not A, B, remember, is because the only time this can be false is if A is true and B is false. So if it's ever the case that A is not true, then this can't be false, right? And if it's ever the case that B is true, then it can't be the case that A is true and B is false. So if either of these options are true, then this thing is true. That's why these are the two options that it splits off into. if either one of these things are true, if not A or if B, then this whole thing is true. Whereas for this one, the reason this one is the way it is because the only way that, like we said, the only way that if A then B is false is if A is true and B is false. And this is saying, this not over here saying it is the case that if A then B is false. So the rule is A is true and B is false, right? But you have to have both of them. So that's why it goes straight down. This one, you can have either one, so that's why it splits off. All right, so now we have this. I'm going to check my last. I forgot to check that one. Now, what I'll do is I'll start off at the bottom of each one of these, and then I'll read my way up and see if there's any contradiction, right? And if there's any contradiction, then I'm going to put an X down here. That's going to mean that this one doesn't work. So not Q, there's no contradiction here. Not P does contradict P right here. So this one gets an X. And actually, I mean, well, I'll do the same thing here. R, there's a not R here, so this one is a contradiction too. But really, I didn't even need to really apply this rule. So if right now you're barely hanging on, then you can skip this little part right here that I'm about to tell you. But really, I didn't even need to apply the Q, if Q then R rule here. I could have just put an X right here. And I'm going to put it in a different color. I could have put an X right here because the not P already has contradicted the P here. So it doesn't matter what I put down here. I'm always going to get this contradiction. That is to make things clean and easy. But again, if this is difficult for you, then I just apply every single rule and don't even worry about it. All right, now looking at this one, not Q contradicts Q. All right, contradiction right there. And R contradicts not R. There's another contradiction. Now, all of these things all these branches we say have closed, right? Every single one has resulted in a contradiction. What that means is, since we had the premises and we said the opposite of the conclusion, we said the conclusion was false, and every time we said if all the premises are true and the conclusion is false, with every single way that this could go, it leads itself to a contradiction. That means there's no way that you can have the premises and say the conclusion is false. Of course, what that means is, if you ever have the premises, you have to have the conclusion. It proves the conclusion is true, right? So this is valid. Valid. There we go. So again, when it's kind of counterintuitive because you're looking at all these X's and it looks like, oh man, it didn't work. That must be invalid. No, that's not. Remember what you're doing. The big deal. Let's use a highlighter. The big thing is right here, right? This little knot. That knot says I'm not looking at this thing up at the top. That's not what I'm doing. I'm doing the opposite of this guy, right? I'm saying can you ever have the opposite of that guy? Since we can't, then we have to have this guy. He must be good, right? I don't know if those symbols make any sense what I just did, so maybe forget that. Let's erase that. Oops. That's not what I meant to do. Oh well. Let's move on to the next one before I get myself in more trouble. Alright, the next one says, let's see here on the homework down here. The next one says, if P then Q, if R then Q, and we want to know, does that entail if either P or R then Q? And you may, if you want to go check, you can, that this we said was valid in the homework before this, right? So the truth tables told us this was valid. Right now, we're doing something to see if there's this other way that we can do things and find out if it's valid or not. Now, let's see if it works. So my first thing I do is my initial list. If P, then Q. If R, then Q. And then I take the opposite of the conclusion. Now, notice what I'm going to do here. I'm going to say not the case. And then I'm going to put a parentheses. But if you look over here, there's already parentheses, but it's not around the whole thing, it's just around this first thing, right? So I'm actually have to do two parentheses. If it's not the case that if you have P or R, then you will have Q. Alright, that negates the whole conclusion. If I didn't have these parentheses, let's see here, if I didn't have these parentheses right here, then instead what I would have is, if it's not the case that P or R, then it's the case that Q. But that's not what I want to say, right? I want to say it's not the case that the whole thing, if you have P or R, then you'll have Q. Without that, it'll just say if it's not the case that P or R, then you have to have Q. That's not what I want. It may not sound initially very intuitive why that's different. Let me rewrite that one. But it is. Rather than get too far into it, I'll just keep going here. So again, now I have a bunch of if-thens, but this one has an or in it. So of course, remember, we're wondering, okay, so which one am I doing first? The first one you're doing, you're going kind of like outside in, right? On these ones, kind of different than the way we were doing before. And the reason is because we're going to have to treat this whole thing right here as if it was an A. All right, so you have like the if A then B, then the not if A then B. Well, A stands for either just like a P or a Q or something like that, or it can stand for like a whole thing. So in this case, A stands for P or R. B stands for Q. All right. So let me see if I can write that. So I have A is right here. If A, then B, and we want to say it's not that. So that's what we're looking at. P or R is that A, and Q is that B. I don't know if that makes it clear or not. I hope it does. It gets a little tricky looking at these bigger ones. So looking at this rule, what I have to write is first an A and then a not B. My A is P or R, so I'll write that first. P or R. My B, or my not B is not Q, so I'll write not Q. And I've done this one, check. All right. My next two are going to be easy, just like the ones before. If P then Q, if R then Q, will just be these two here. Of course, I'm going to have to split them out again. So I'll say if P, say not P, right? Because the rule is not A or B, right? And then Q over here. Done that one, check. For some of you guys that are a little quicker, you'll see this not Q and Q contradict, so you could actually X this out and not go any further if you wanted to. I'm going to show you the rest of it. I'll go here and do the not R, Q, not R, Q, check. And then the last thing I have to do, I have to worry about this gentleman right here. Even though it was sort of buried in this, P or R here is still has a rule that can be applied to it. So I still have to apply this rule. And the or rule, remember, A or B is true when either A is true or B is true, or possibly both. So the possibly both is covered by either one of these things being true. So if A is true, then this thing is true. If B is true, then this thing is true. So I'm going to split these off again, and I'll say P, R, P, R, P, R, P, R. Oops, that's right. And then check. Now, I suppose you could see kind of why you would want to clean things up way early, because you would have, if you had put the X over here, you wouldn't have to write all this mess. And now we have 8 things we have to worry about. So probably in the next couple, I'm going to start doing that. But for now, let's look at this one. P contradicts not P. So I have an X down here. This branch closes. R contradicts not R. This branch closes. P contradicts not P. This branch closes. R doesn't contradict anything, but Q contradicts not Q. So this branch closes, right? If there's a contradiction anywhere in here, it doesn't have to be every single thing contradicted, just one contradiction somewhere in the branch. Notice also that I'm not going down branches. I'm going from the bottom up branch all the way up the branch. And notice that I'm not saying R and I'm looking over here and skipping over into other branches. I'm not doing that, right? Just going straight up a branch. All right, on this one, I look up P, no contradiction there. Not R, no contradiction there, but Q and not Q contradict, right? I'm going from here, Q, not Q, and that's a contradiction. So this one is a contradiction, right? R and not R contradict. No contradiction to P, but Q contradicts not Q, so this one has a contradiction. No contradictions with R, but Q contradicts not Q, so this one has a contradiction. So they're all X'd out. So again, this one is valid. Remember, it's valid even though you have all these X's down here, even though it looks like nothing worked. That's what we wanted. We didn't want anything to work. We wanted to see, because we took the contradiction of the conclusion, we wanted to see if you have all the premises true, but the conclusion false. Can that ever work? And we just showed no, it cannot work. So if you can't have the premises and the opposite of the conclusion, then you have to have the premises and the conclusion. Right? The conclusion has to be there. So we have proved that the premises proved the conclusion. That's what we're doing here. All right, let me see what time we're at. I think probably we'll take a break here. I'll make another video in just a second here, and then that way this won't be too long.